Hi everyone, in this video we're going to talk about a complicated two-variable truth table and we're going to draw some conclusions about it. So let's look at the actual question here. So we have not P implies not Q, and then biconditional not the entire statement P or not G. That's a lot. So let's break it down piece by piece and let's do it together. So with every truth table, you want to start with the basic variables that are in question. You have P and you have G. Well, let's describe the four situations that can happen. You can have one case where they're both true, one case where they're both false, and then alternating truth values, like that. So both true, both false, one true, one false, one false, one true. Great, easy enough. Well, that's just the beginning. We have to now go piece by piece and try to understand all the little pieces leading up to the final sentence. So, not P, that's the first question. Well, that should be pretty easy because not P is just the opposite truth values of P. So instead of true, true, false, false, we have false, false, true, and true. Okay, same idea with not G. Not G is just the opposite truth values of T. So T, F, well, we're going to go backwards with that. Now it's false, true, false, true. Okay, so now we have all the pieces required to attack this conditional. Now you have to remember the rule for a conditional. The rule for a conditional states that the only time the conditional is false is when the antecedent is true, which in this case is not P, and the consequent, in this case not G, is false. So if you get true implies false, then it's false. So let's look. Not P implies not G. False implies false. That is defined as true. And then next one, false implies true. That is defined as true. True implies false. Now that's the one situation where it is false. And then true implies true. That's true. Great. This column's done. Now let's look at the next one. P or not G. Now we have to be careful here. We're looking at P, this column. Let's throw a little color on there. And we're looking at not G, which is this column. Let's throw some color on there. So let's just make sure we know the rule here. Or, the rule for or is one of them has to be true. If P is true, or if not G is true, the whole sentence is true. Great. So let's see here. True or false. That is true. True or true. That is true. False or false. I'm on the third column here, or third row. False or false. That's false. False or true. Hey, one of them is true. That means the whole sentence is true. Great. Now notice this next sentence. This next sentence is just the negation of this previous column. So instead of going down piece by piece, which we could do, instead we know that it's just going to be the opposite truth value of this sentence. This is why we constructed it in this way. So false, false, true, false. And now we have all of the pieces. So let's get some color. Let's remove the color here. We don't need these anymore. Instead, let's look at the actual two big pieces. We have this big piece, which I'll include the actual sentence. Let's put that in some blue. And then we have the other piece, which is this one. And let's use that same color. Now, this is using the biconditional arrow as a connective. Now, in case you're not sure what that means that it's only true when they share the same truth value. So let's go piece by piece here. True, biconditional, false. Well, they're different truth values, so it's false. Final sentence. Let's just take F. Okay. True, double arrow, false. That's also false. False, double arrow, true. Hey, that's false. And true, double arrow, false is false. Okay, so then the final sentence has an entire column of false. What does that actually mean? How do you interpret that? Well, there's actually a name for this. And it means that no matter how you construct this sentence in all four cases, whether they're true, they're false, or there's some combination, the final sentence is going to be false all the time. That is called a contradiction. So a contradiction, let's not do that. A contradiction is when every single variation of the sentence is false. So you say the conclusion that we drew is that it's a contradiction, and contradiction, and that no matter what situation presents itself in terms of the truth variables here, the final result is going to be false. So that is the conclusion that we draw. We say contradiction, we center it, it looks nice, and we tell ourselves that no matter what happens in the situation, this is false. This is an example of two variables. No matter where you configure them, it's false, which means it's a contradiction by nature. Nothing is true in these sentences, at least in terms of the final result. Okay, so again, make sure you understand the application of it and how to understand it in the grand scheme of things. A key piece here is you have to know about the rules. You have to know the conditional rule, you have to know the or, you have to know the biconditional rule, the negation. All of those pieces come into play when you start messing with a larger table like this. I'm going to be making more videos about 3 variable truth tables, maybe give a complicated version of one of those, and maybe even 4 variable truth tables, because it can get quite complicated, and it's important that you know all of the pieces, all of the rules, all of the steps, so that you can attack them in your own work. Awesome. Thank you, and let me know if you have any feedback. Bye.